Hey gang, today we're going to be multiplying and dividing by a monomial. When multiplying by a monomial, multiply the numerical bases, then multiply variable bases by adding exponents. So here are some examples. So we've kind of seen this before, we just want to reinforce the skill and make sure we've got it down. So 8 times 3 is 24. X, there's no other x to multiply by, so it's just x. Y, there's no other y to multiply by, so it's just y. And z, there's no other z to multiply by, so we just get z. Here we have negative 3x squared cubed, so that's negative 3x squared times negative 3x squared times negative 3x squared. So we have negative 3 times negative 3 times negative 3, which is negative 27, not positive. X squared, and x squared is x to the 6, adding the exponents. Then 6c squared d to the 4th times negative half d is negative 3 because 6 times a half is 3. C squared, there's no other c to multiply by, so it just stays as c squared. And d to the 4th becomes d to the 5th because we have this extra d over here. So it's negative 3c squared d to the 5th. Now, down on the bottom row, we have more than just a monomial that we're multiplying by. So we have to distribute the number outside. Negative 5x times x squared is going to become negative 5x cubed. A negative times a negative is a positive. 5 times 2 is 10. X times x is x squared. Then negative 5 times positive 4 is going to be negative 20x. And just a reminder with that one, that's a trinomial with a lead coefficient of negative 5 and a degree of 3. Next one, we do the same thing. We multiply negative 3 times 4, we get negative 12. A squared times a is a cubed. B squared times b squared is b to the 4th. Then a negative times a negative is a positive. 3 times 3 is 9. A squared stays, and b to the 4th, because b squared times b squared is b to the 4th. And then lastly, multiplying that negative r cubed, s cubed over both terms gives us positive 2, r to the 7th, s to the 4th, because 3 and 4 make that 7, and 3 and 1 make the 4. Then plus, because a negative times a negative is a positive, 3, r cubed stays, and s becomes 7 because we have s to the 3rd and s to the 4th. All right, so that's multiplying. You multiply the numerical bases and you add the exponents of like variable bases. So now you're going to try some of those on your own, 7 through 10, and then pick up back here. So now when you're dividing by monomial, you're going to divide or simplify the numerical bases, and then you're going to subtract the exponents of variable factors with the same base. So here we have some examples where it's just a monomial divided by a monomial. 12 divided by 4 is 3. M to the 7th over m to the 5th is m squared. N to the 2nd over n to the 3rd is n to the negative 1st. Over here, 14 over 21 cannot be divided out because it's going to be a fraction. So we're going to have 14 over 21 divided by 7 is going to give me 2 over 3. Then we get x to the negative 1st and y to the 4th. Continuing with dividing, we have now a binomial divided by a monomial. And the only way this works is if each of the factors in the numerator are divisible by the denominator. Otherwise, this method is not going to work. So we have 9 divided by negative 3 gives us negative 3, and y to the 9th over y to the 3rd is y to the 6th. Then plus, because we have a negative over a negative, 6 divided by 3 is 2. Y to the 6th over y to the 3rd is y to the 3rd, subtracting the exponents. And then in 17, same idea. 24 divided by negative 6 is negative 4. X cubed over x is x squared. Y to the 4th over y is y cubed. Plus, because we have a negative over a negative, 18 divided by 6 is 3. X squared over x is x. And y squared over y is y. And last, negative 6xy divided by negative 6xy. Well, remember, anything divided by itself is just 1, so we get plus 1. It doesn't cancel it out. So now you're going to try the ones we didn't get to on your own. I'll be coming around to check on you to make sure you've got it right.